Hi, this is Graham Bell with Real Intent. I'm speaking with Dr. Roger Hughes. Roger, you've been with Real Intent for several years and helping customers out with verification problems. What kinds of designs are people working on these days, and what are some of the issues they're struggling with?
They're working with very, very large designs, typically of the order of 50 to hundreds of millions of gates. Some of our customers actually are doing 200 million gate plus designs. Some of the blocks are quite large, and so they're trying to process the overall design in one go, but they're also addressing a lot of power issues, and power is necessitating the use of multiple different clocks, and all of these clocks require the use of clock domain crossing verification because they are asynchronous with one another, and as soon as there is any data transferred from one clock domain to another, there's a potential for metastability.
Now, these blocks, are they all developed in-house, or are there third-party suppliers that people are using and aggregating these different IPs together?
It varies from customer to customer. Some of our customers do have all their blocks in-house. There are vast many that are actually taking blocks from companies they've acquired, and there are blocks that they're outsourcing out for other companies to provide. So there's a lot of external IP that gets brought into these designs for design reuse in order to get very large designs produced quickly. It's impossible to produce a 200 million gate design from the ground up in just 6 months. You have to do some design reuse in order to be able to do that.
So there may be some different clocking schemes or different registration schemes people are using at the interfaces, depending on who developed the IP and where it came from. Well, are people just using, one or two clock domains, or how large a problem, or how many different domains are they looking at?
You're looking at designs with many different clock domains, so you might have 100+ clock domains with several clocks within each domain. So you're talking about several hundred clocks on a very complex system chip these days.
Well, it sounds like you couldn't use manual methods or bug hunting approaches to ensure that the design was correct.
Absolutely impossible. The complexity is just beyond what manually can be easily done.
So if you run an analysis tool, what would be an expectation for runtimes? Should I have answers in a day, or should I have answers in a minute? How long does it typically take to do this kind of exhaustive verification?
I think you've got to break that down into two fields. One is the tool runtime, and the other one is the manual debug in terms of understanding the reports that a tool generates. Firstly, in terms of tool runtime, our Meridian CBC software is very, very fast, so we can actually process 100 million gates, typically in an overnight run of less than 10 hours. So that can produce all the results required for a full system chip design with all crossings identified and reported, and then you'll see all the warnings on different crossings, and then it's a question of analyzing those warnings to work out what's wrong potentially with the design, or to see if there's some environmental changes you need to make in terms of reassociating different clocks in terms of different clock domains.
Well, people could be buried under a lot of noise in one of those kinds of reports. What's the best way to kind of control that so that designers aren't overwhelmed?
The best way to control it is to use Meridian, because that does already reduce the noise significantly. It will do bus collapsing, and it will really focus on just the key errors that are essential. So it orders the errors in the most important category first, so that if you look at those first, you will resolve most of the remaining errors very, very quickly and just do a rerun, and then you'll find that a lot of the problems will be eliminated after a few design changes.
Roger, thanks for speaking with us today.
You're welcome.